Hello, algebra. All right, we did some work and I went over some values tomorrow. I'm going to do some formulas for you today that you may want to just write. No, not may. You want to write them down. They're going to be helpful, especially with the final exam that you're going to have to take in a couple of weeks. We went over one of them yesterday, and that was the geometric sequence formula. Okay, geometric sequencing. We did that one yesterday a couple of times. I'm going to use this geometric sequencing right here. The geometric sequencing formula is a sub n, a to the nth term, whatever the term is they want you to go to, is equal to a1, which is the initial number where you start, times the rate of change that you're changing by. If you remember the rate of change, you just take the two numbers and divide them essentially. The second number divided by the first number, the third number divided by the second. That's going to give you your consistent or your constant rate of change. And then to the n minus 1 power, the whatever power that you, this term they want you to go to, that's when they say the nth term, whatever nth term they want you to go to, subtract 1 from it, and that will give you your new number in your sequence that you will use. Now, how would I use that? Oopsie. How would I use that? That would be like in the ones that go over like number 13. What is the 11th term in a geometric sequence that goes 4, 12, 36? Okay. 4 would be your initial number. The rate at which it changes. What's 36 divided by 12? 3. What's 12 divided by 4? 3. Okay, so the rate at which it changes would be 3. They want you to go to the 11th term, the nth term. So these would be 11, but 11 minus 1 is 10. You get to use a calculator with this crap. So when you have to take 3 to the 10th power, you just go to your calculator and go 3 caret 10 equals, and then multiply it by your initial term, which was 4. And that's going to tell you what your 11th term in this geometric sequence would be. So if they give you a geometric sequence, or they give you a sequence of numbers where it is changing by a multiplication or division, you can find it. Now, formula number 2. Actually, I'm going to give you 2 and 3. Exponential growth and exponential decay. It's basically the same formula. Exponential growth and decay is very similar to the one, let's see, bacteria. The bacteria culture problem in number 11. If y is equal to 10 times the quantity of 2.4 to the t power, and they give you time, it's basically an exponential growth or decay problem where they filled in everything for you because, they don't think you know the formula. All it is exponential growth or decay. If it's growing like the bacteria problem is, if it's getting more as time goes on, y is equal to a, which is your initial number, times the quantity of 1 plus r, that's your rate, again, your rate of growth, and x is the number of years or time that it's gone by that it's going to occur. So let's look at that bacteria problem that they give you and see if we can fill in what they got here. Okay, the bacteria time is 5. Okay, so obviously x would be 5. The rate of growth that they did all this for you, 2.4, more than likely the rate of growth is 140% growth over time. Oh, this is a bad bacteria. Ugh. Okay, and your initial count were 10 of them at a rate of growth of like, ugh, yuck. Okay, 140% growth. So 1 plus 1.4, because you change your rate into a decimal, so 140% would be 1.4. So 1 plus 1.4 is 2.4. This is disgusting. So the growth rate of this bacteria is pretty hideous. So you have to take 2.4 to the 5th power for this problem for it to work. Again, it's a calculator problem. They give you all the parts of this one. All you had to do is put the 5 in for the t and take 2.4 to the 5th power, 2.4 caret 5, or 2.4 times 2.4 times 2.4 times 2.4, 5 times, and then take that answer that you get times 10. And that's going to tell you how many bacteria there'll be over 5 years or 5, whatever the amount of time is. Let's just say 5 minutes. Ugh. Okay. Now the last one, compound interest. This is a big one because you've done simple interest. Simple interest is that thing where you just take principal times rate times time. Principal is the amount of money that you start with. The rate is the amount of money that you're either getting in interest or paying in interest. And time is how long they give you or how long it's for. So the principal times rate times time problem for simple interest would be this one. You take $50,000 piece of machinery at a value of 13% per year. It depreciates at 13% per year. What will the value be? Now, the key to this one is you could do exponential decay for this one. How could you do exponential decay? Well, let's see. $50,000 is the initial amount. The rate of change is 13%. Okay, 13%, you have to change it to a decimal. That's 0.13. That's your rate, 1 minus 0.13. And the amount of time that it's going for is 4 years. So you could use exponential decay right there. $50,000 minus, or 1 minus your rate, which is 1.3, to the fourth power. And again, you can use a calculator. You could have used the compound interest. The principal is how much you started with, $50,000. Okay, the rate of change is 13%, that 0.13. It doesn't tell you how many times it compounds per year. That's number 12. That's compound interest. So you don't need to worry about this. This is an exponential decay problem. So exponential growth, exponential decay, compound interest. They leave off a little bit of money on that one to be able to use the compound interest. Now, this one, number 12. How much would you have in your account if you invested $900 at a rate of 5%? All right, let's do that one right now. I'm going to use my blank board to write this one up. You're going to use the compound interest formula. Principal, rate, the number of times it's compounded, and then the number of times compounded times the time to that power. Okay, I'm just going to fill it in. You can use the calculator to do all the grunt work to get this. All righty. It says, how much would you have in your account if you invested $900 at an interest rate of 5 compounded monthly for 6 years? Okay, so it is A, which is the compound interest, and the principal that you started with was $900, okay, times 1 plus the rate that it was changing was 5%. You have to convert it into a decimal. So that's 0.5%, 0.05. 0.05 converted, but now it's divided by the number of times that it's going to compound in this problem. Now here's the key. It's compounded monthly. How many months are there in a year? 12. Okay? That's how many months there are in a year. Now, it's taken to the power of how many times it's compounded, n, and for how many years that it goes, times 6. Yeesh. This is another one. You get to use a calculator. Just this little bit right here is a disgusting little pain in the butt. 0.05 divided by 12. Okay, so this problem, you take 0.05 divided by 12 plus 1. Then take that to the 72nd power, whatever that number is, to the 72nd power, and then take that answer times 900. Pretty good investment getting 5% monthly for 6 years. That $900 is actually going to get pretty big. If you guys can get that kind of a deal in your interest rate work, do it. Run with it. Okay, so let's go over those formulas one quick time. Then I'm going to be posting some stuff in a little bit, and you can work on the problems that deal with geometric sequences. Geometric sequences are a sub n, that's the nth term, is equal to a to sub 1, that's the first term, times r, which is the rate of change that you've got. And how do you find the rate of change in a geometric sequence? Take 36 divided by 12, that's 3. Take 12 divided by 4, that's 3. It's a constant rate of change. Okay, so the rate of change would be 3. And then n, which is the term they want you to go to. Oopsie, wrong problem. That's the 11th term, whatever, that's the n minus 1. Now, exponential growth and decay, that's like for numbers 10 and 11. Those are exponential growth and decay problems. Exponential growth is A is equal to A. If you know one of them, you know them both, because the only thing that changes is the plus and minus sign. A, the initial number, the amount, times the quantity of 1 plus the rate that it's changing, or 1 minus the rate that it's changing, all to the number of years or the time that it is the decay or growth. Okay, so if you look at number 10, it's $50,000 piece of machinery. That's the initial amount. That's A. Depreciates at a value of 13%. 13%, you have to convert it to a decimal, 0.13 for 4 years. So when you come over, it's decay, it's depreciating. Initial amount is $50,000. 1 minus the rate, which was 0.13, all to the number of years that it's going to go, which is 4. Okay, so that's how that one works. Now, compound interest. Simple interest is easy. Simple interest, that's why it's called simple interest. And you want to test something? Do the simple interest for this problem, and then find out how much more you make with compound interest. Now, there's a little deal that some people have made with like jobs and things like that, where, okay, we'll make sure we pay you not compound interest. We'll just pay you simple interest on that year. So you're just going to get a simple interest like this one, 5% per year that you work. So they take the money that you have at the end of that period, and you get 5% on the original amount. Whatever. It's compound interest is phenomenal. Do not let somebody take compound interest away from you. You are big. So by compounding your interest, you're compounding the amount of money. Now, compound interest is principal times the quantity of 1 plus the rate divided by the number of times that it's compounded, all to the power of the number of times it's compounded times time. So in the compound interest problem, 900 is the principal. The rate of 5%, that would be 0.05 for the rate. It's compounded monthly. There are 12 months in a year, so that's 12, and that would be 12. Important number, it's in here twice. N is the number of times that it's compounded. That is the monthly, so that's 12. And T is the time, and the time for that one is 6 years. So you just fill in those parts, do the math, use a calculator. You're big boys and girls now, young men and young women. You can use a calculator for this garbage work. This is what I would call garbage work. Busy work, where it's just a lot of just number crunching with that. It's not mental math. All right? So those are the formulas. I'm going to just have them on this screen for a few seconds. You can copy them down. I'm going to come in with another video for the stuff that we're going to be moving on to, and I'm going to post another worksheet. If you have any more questions, we've had some good ones, I'm going to go over them in a little bit, but we need to make sure we understand that we can do these problems, and they are not that difficult for us. Okay? Don't get freaked out because, oh, it's written in words. Words make me cry. Come on, seriously. They're application problems. Don't call them word problems.